Hi everyone, thanks Michael. I'm Riley. I'm a co-founder of Pear and also a programmer at Pear. And this talk is about some of the best practices that we've developed at Pear to help us do what we call UX-driven design. But before we start, I really want to give you all a big thank you, because this talk, like us here together, is actually really a big deal for me. We're going to show you what currently is like the best that we can do at Pear. And it's kind of a scary position for me to be in, because if you're better than this, then like that's scary. But I love to be in a place where I can invite people on Slack, basically, to come, and 40 people show up to supportively, I assume, hear what my best is, give me criticism and ideas and feedback, and I just love living in a community where that's true. So thank you guys very much for coming. All right. It's serious. Like, I think it is worth. Thank you, Jerry. I'm like embarrassed saying things like this because it's emotional and stuff, but it's really important to me. So thanks a lot. This is my carefully prepared. I actually have been practicing this for 3 days. I really have. It's not sarcastic. So yeah, this talk is about the best practices we've developed around Flux and how they're helping us do UX-driven development. And Pear has always done UX-driven stuff. And before Pear, the co-founder's last company, ActiveGrade, was always UX-driven. We started with real problems from real people first, always. And then do lightweight prototypes, like on paper, and do the design session thing, right? Where we come up with a design, a potential solution to a problem. And before anyone's programming anything, we're doing user interviews and testing that people can get to their goals and things like this. So we've always been user experience driven. But we found that even though we were doing UX first, we were doing UI kind of last. So like these amazing design sessions would happen, award-winning design session. And we would finish up with these UX design sessions, and then like the first thing I would do is like start estimating how long the API was going to take and start building the API. And like 2.5 weeks later, I would have the API ready, and then Dan, our amazing vice president of design, who actually is an award-winning designer, would first start to get to make what I had made look good. And so 3 weeks after our design session, we would be able to do an actual demo with the actual features. Oh yeah, I'm supposed to ask all these questions and I forgot. So like first we made the API, and then look at the Chrome console. Everyone loves the Chrome console. And don't read it, my secret keys are in there. And so finally, after weeks, I would get to this. This is literally a design that I made. It's a list of classes with a list of students for each class. You can clearly tell. And then would get the chance to turn it into this. You can see why he wins awards. We would do a demo. Someone would suggest a change, and I'd be like, are you kidding? I just spent 3 weeks on the API for this. Let's ship this. That's what we agreed on. Not really, but it was a huge pain to change it. So recently, we started flipping this around. Instead of doing the design and then doing the API and then connecting the API to our clients and then finally making the design work, we started first going, oh, everybody does it. You're on your phone, you can be like, yes, I agree. We didn't practice the interaction part. If your phones are still open, you can agree with me or not agree with me so far. We could go back and answer the other questions I was supposed to ask later. Yeah, we got to figure out how caffeine does it. We need a mobile app, if you know any mobile app developers. So now here's what we do. This is the thing. This is what our talk is about. We started first immediately making the crappy UI. It doesn't work at all. It literally has fake data in here. And we make what we call a dev panel, which is a list of buttons that Dan can click to go to the different states. Like, it's actually in our app. It's more than a prototype in Photoshop. But it's much less. There's no API here. And he clicks start loading. He clicks and immediately starts making this. This is like the same day or the next day after our design session. We're seeing this. But importantly, we're also seeing this. What happens when you haven't authorized for Google? He can click to see this. He can see what happens if there was some error and make that look good. Again, we haven't programmed anything yet. But already we can go to a demo that even includes what the loading what it will feel like for the thing to be loading. Do a demo with actual people, and the time from design session to being back with humans experiencing our thing has been shortened to like 1 or 2 days. And frankly, like this error is so freaking annoying to get as a developer. Here's how you get this. If you actually want a permission error, you have to log into Pear Deck, grant the permissions, enable this integration, go into your Google account settings, delete Pear Deck, go back here, reload the page, and then you get like this permission denied thing. And if you make the mistake of clicking try again one time, it will automatically reauthorize you, and you have to go and do the whole thing again. So if Dan wanted to just like change the size of the header, right? It's like an 8-minute process. But now he can press Command R before we've even programmed the stupid thing. It's freaking incredible. So while I'm talking now, you can draw Joel's face or clothing onto this pear. We started all of this. Facebook has been talking obviously a lot about React and Flux, and this is based on what React does. Joel's going to talk about how he helped us move Pear Deck past what Flux is. And are you getting our error page? See how nice the error page looks? Dang it. Actually, if you could send the X-rays over there. Joel's going to talk more specifics of how this works technically, and I hope that's what you're here for. We promise a technical talk, and it will be. But the important thing for us is really, we're doing UX-driven development at first. Let it be easy for us to develop the UX.
Show the pears.
We can show the pears. Nice picture. Here's Joel. It looks exactly like him. Oh, man. This is incredible. Wow. This is, you guys, this is Joel's wife, I think, drawing his wife.
That is Joel.
Oh, very clear and direct. I like it.
Wow, I'm impressed.
So, by way of introduction, Joel most recently has been seen at the JavaScript meetup teaching everyone how to make web apps in Elm. Without further ado, please help me welcome Joel Jeddaloh. Oh, sorry.
Oh, we're back to this. Awesome. Awesome. All right, guys. I'm going to try really hard not to get in the weeds here. There's so much I want to talk about. I'm going to gloss over a few things and just know that we want to discuss this, right? We want to have a good discussion about what's going on. And so we'll have plenty of time to answer questions and go over. But if I gloss over a few things, sorry about that. So at Pear Deck, there's like 4 parts of the app that we kind of think about. And in general, we think about there being this flow where our UI calls an action creator and it dispatches an action that goes into our store where all our state is, and that gives a new state to the view, which renders that to the page. And even though that's kind of how conceptually we think about the flow through our application, as Riley mentioned before, the page, the end result, is really what it's what matters, the end result of our work. And so we want to get as close to that as we can. And so we've flipped our development process around such that we work at that view level as fast as we can. So we can iterate, we can figure out the interactions, we can polish those things up, and we move backwards kind of through the flow of our application. So as I dive down into each one of these components, I'm also going to work backwards from the view. And I hope that gives you a little bit of insight into our mindset as we're developing the app and what we're looking at. So the view part, we have some state in our application, and the view is just going to spit out the DOM. This problem has been solved before. This is Angular. This is React. In specific, at Pear Deck, this is React. It used to be that we had a page and we had a button that would jQuery go click and hide something and do something. We had state separated out throughout our application. It was hard to reason about, hard to figure out. But now we just say what is, and our view knows. It knows oh, slide 2 is active. I'm showing slide 2. It just knows how to do that. So our view is literally a view. What's on the page is just a direct representation of our state all the time. And so we always are considering our application logic and what our state is there. And that unburdens us from so much complexity that's going back and forth in there. If you're not on this bandwagon yet, run out of this building like it's on fire, go learn about it because it's going to change your life. But I don't want to go too much into that particular thing. So let's pretend we're running a view. Like, at Pear, we use Angular, we do all kinds of cool stuff, but I literally said it's a function. It takes a state and it outputs a DOM. So let's pretend that's exactly what we're writing. So here's our function, and the first thing we do is like, oh, Dan said we have to have a loading screen, right? We're going to start building like this small section of our classroom integration where we're going to fetch some list of classes, and then we're going to display them in some list somewhere. So we know that's going to be like, it's going to be an asynchronous operation. So let's get a loading screen going. So if loading sections is truthy, then let's just return an HTML string of our loading thing. Awesome. If we're not loading the sections and we have some sections to display, let's render a list. This particular list always renders the same two sections, kind of useless, but it's pseudocode. But the point of this thing is that we're immediately working at like the final layer, like the final level of what we're going to deliver. And this helps us to like kind of figure out what the shape of our state might be. It gives us some insights here or there. And we'll go back and forth. We'll like, we'll do some stuff in our state and we'll come back to here, but it really helps us to like see what things are. It used to be that I would start at an API and I would work like out from there that was in a way that was convenient for me. And so it might be that like I actually get to the final endpoint of our application and it actually doesn't quite fit how our thing works. So I think it's really valuable to start here and work back. So we need some state, right? We're learning about our state. We're using these views and stuff to help inform our state. And the store is where our state is stored. We use Flux, like there's some terminology, you're gonna recognize that, like from Flux and things, but we also have some very strict regulations and like in how we use Flux that's a little bit different. And so at Pear, our stores can only do three things. They can listen for incoming actions, they can respond appropriately to those actions and update the state, and they can send a new state off to the view. And that's it, that's all they do. So if we look at our store here, the first thing we do is we define our state. So our loading sections are, we're not currently loading, we don't have any actually sections loaded, we don't have any errors going on, and so, great, like it's not gonna be showing anything. This is so nice because my state's just here. When I wanna see what the state is, I just come here and I see like what's possible. In fact, there's probably a type signature at Pear that tells you even more information, like, oh, is this thing that's like, it might be here or it might not, like these are an array of these specific things. This is so nice to know where your stuff is and not have to like keep this in your head about what can change what or how things go. Okay. So the next thing we do is we just register an action handler. So all line 7 is saying is that when the sections requested event comes in, we're just going to set loading sections true, right? So somewhere, like there's an input to our system that says someone requested to load the sections. So let's like start the loading spinner. Obviously, we're going to want to receive some sections, so we're going to respond to that action coming in. It happens that our actions can have some data on them as well. So this particular thing takes in a section, a list of sections. We're going to stop the loading spinner from going, and then we're just going to put the loaded sections onto our state. So this is also like, we're changing state, but I mean, this is really easy to reason about, right? And in fact, we have some other things at Pear where we don't. We do use immutable stuff, but I won't get into that. We'll get into that later, maybe. So if we want to look at what kind of actions come into our system, here just for fun, we have a type signature of a section action. This is like what might come into our store. So it's just an object that has a type, and it has some name to the action. So our sections received also, like, it just has a type, but you can also put anything you want on the actions. I mean, some extra data. So we're going to send along, this should actually be sections, an array of sections that we want to display. And so like we might get some other actions like user denied permission, received unexpected error, or whatever these things are. But there's one thing to note, I think, about these things, and that is that like they're all past tense, right? So we have some like kind of strict naming conventions around especially our actions and our action creators, because if you think like what we've done up until this point, we haven't really done anything. We haven't made API calls, we haven't done whatever. Like, it's almost a pure function. Like, we get input, like we get a state and input, and it just we render like our page to the DOM. And so we've kind of isolated a lot of complexity, right? We have this huge part of our app. This is it. Like, at this point, we can like demo a whole bunch of usefulness. We can just send actions into the system, and we can like demo interactions and things that we want to do, and really work that a lot at this point. And like this part of the code is just totally synchronous. It just flows straight through. Like, this is an easy thing to reason about. And I think that's really important. But speaking about being easy to reason about, eventually we have to deal with the real world. And thus we come to our action creators. So our action creators are this is where we do our async requests. These are where we have our API calls. This is where we have to like deal with the fact that a request might fail, or like they just succeed, but they return complete garbage. So we keep all the crap like that we don't want to really have to deal with, all the dirty stuff, like it's in one spot. And this kind of creates an insulation like between that crap and the rest of our app. So that means when we're in the rest of the app, it's really nice. It's just the most nice development experience. You don't have to worry about anything. And when you're here, like you're dealing with the crap stuff. But we want to make sure that we're not just like moving complexity from one part of the app to here, like all the crap is condensed into one place. But it turns out that if you have all your crap in one place, it's actually really easy to wrangle it. And one of the things that we really that helps us to like get a handle on this stuff is we have a rule in our action creators that says when you create an action creator, the entire life cycle of what that action creator is going to do has to be visible within the action creator. So that means that as soon as I look in this action creator, I'm going to see all the actions that are fired off by it, like dispatched outside. I'm not going to like call an API and like deep down in some file loading thing, like get a file back and then dispatch an action with the contents of some file somewhere. Because I can't reason about that. I don't know exactly what's going to happen when I do that. Like if I have some asynchronous stuff, I'm going to deal with all the results right there in the action creator. I'm going to also like make sure that my errors are handled. So when I'm going to call an action, I can look at it and I know like everything kind of that might happen deep inside of it. So let's say that like here we have action. So like generally like we call action creators from the UI. So someone clicks a button that's like invite our sections. So like now we're going to get a list of the sections. We're going to load them into the app. So we're building here our action creator. So we can just call load sections when we press a button or whatever. And the first thing we're going to do is we're just going to dispatch the sections requested event. And at this point, we don't really care. Like, I mean, it's going to eventually like trigger our loader, right? But we know we have an asynchronous call, so let's just dispatch this thing, and like our other parts of our app can deal with it as they see fit. Now that we've done that, we get to the dirty part. So we're going to load sections from our Google API. And I'm sure that is like a super awesome piece of code. I'm sure it's complicated and does whatever. But at this point, we don't care, right? Like when you're in the load sections from Google API section of our code, you're just concerned with returning the sections for the code. Like it can be as complicated as you want. At this point, like we've separated those concerns. So on line 5, if we actually get something back, we're going to get the sections. And we're just going to dispatch the sections received event along with the sections. And we know how that works, right? Like our state will be set there, and our view just automatically renders itself, and it's fantastic. But especially here, we're building this classroom API, and we have to deal with like all of Google's APIs. And in particular, we have to deal with all the crazy permission stuff. So when someone goes to connect to Classroom, they're going to have to authorize their stuff. And of course, you're going to be like, oh, they wanted to do this, they'll authorize whatever, but they're going to cancel, for whatever reason. I don't know why, just for fun. And then you're going to get this error, like permission not granted. So here we're going to dispatch the user denied permission thing, and our UI will say, no, really, like we actually did need that thing. But if we got something else, then we'll dispatch an unexpected error, and we can show some other modal that says, oh gosh, actually something broke. Like here's the error, send us something. So this is how like stuff like we call our UI calls our action creator, and then it just flows straight through to our page. And we came to this architecture and like decided to do this because we wanted to work, closer to that view layer. We wanted to iterate faster on that. But one of the cool things that we didn't expect when we did this is that because everything enters at one spot in the system and then just flows through, we can inject ourselves at any point, which is what allows us to actually work backward and have functional stuff as we go. So let's just give a little demo of how we do that. So we're at our beautiful Pear deck, and we want to make our new classroom thing. We want to list our sections. So we always have a dev panel at Pear deck. So you can't read this stuff, but our state is down here, right? It's just giving you a visual representation of actually what's going on. And as a developer, I want to send this over to the designer. And so I've just set up a few buttons, and all they're going to do is they're just going to send those actions, the same actions that we saw before, with that same, like a little bit of fake data, a class here, a class there, whatever it is. And so that means that I can send this over to Dan. I don't have to tell him like, oh, go to this branch and then do these things. I just have a bunch of buttons, and he can here's our loading spinner, here's the class list, here's the generic error that the only way we could get this is to cripple our application on some branch and commit it and send it over to Dan so we can style it, and then he gets it back or does something weird. We have to or this one even worse, where it takes you 20,000 hours to even get back to here. And then he said oh yes, I authorize, but then he forgot, shit, did my no thanks button work? I don't know. He can keep doing it. He can keep testing these things all day long.
And we haven't programmed the API yet.
Yeah, we haven't done anything at this point. All we've done, I've set up a state, and then I have some actions, right? I haven't done all the hard work really is in the action creators, right? All our API stuff, all that stuff. We haven't done any of the hard work at this point. And yet, we can just test the entire flow of things. And I even want to invite some stuff. It probably would work. But as you get further and further through the process, you can really test multiple interactions between your things. But because we know our states, we know where our state is, right? It's not spread throughout the app. It's not mutated in all these different places. We just know where it is. So anytime we want, we can just grab it. So let's say there's this class list, and I select this thing. But I think I'm a better designer than Dan. So this thing should have been hot pink, and I really feel that he should have done this thing. And so I don't want to go here and be you have to just select this thing that's blue, but it should be hot pink. I really just want to send him right here and be wouldn't this be better if it was hot pink? We have this special little current state link. Let's just push that into a new tab. We could go somewhere else. Let's open that in a new tab. So we can be moving through our application, do whatever we want, and then we can just grab that state and do something with it. So in this particular case, we just jammed it onto the URL. So here we are. Here's this thing. And in fact, here's our two states, just set up in a different URL. And in fact, maybe you want to close this or interact with this particular thing. You can just refresh the page, and you're right back where you started. So that means you can be going through the app, you can hit an error, or you can find something. You don't have to screenshot it. You can literally just send someone to the exact state that you want them to be looking at. So once we can there's just so many possibilities for this. Once we can start rendering, once we know what our state is at any point, we can just push it anywhere. So now our Trello cards, they're not oh, hey, Dan, go to this branch and style these things and work on these interactions. Instead, it's literally here's 5 links. You're done. Just go exactly right there. Imagine if our bug reports, they came with the state that was present right before you got the error along with the action. You could just replay it right there every time you wanted. You could send it off to a continuous integration server, and now you're at this exact state that you want to be, and you just need to test this interaction continues to work. Or also not only is our state in one place, but all of our interactions come through and enter at one point. So we could just like log them, and we could just send those off to another device to replay the entire session. So now I can like make sure that all this like set of actions work on Firefox or in like some Android device or like whatever we wanted to do. And we haven't gone over this, but like our states are immutable. I mean, our stores are immutable at Pear, so we're not even that far from a time traveling debugger. So we could be going through our app and it's like, oh God, I got this error, what happened? Just reverse it and like replay it and see your thing and fix it. You know exactly, especially if it's like one of those errors you're like, I finally got it, what caused it? Like, oh my God, that would be so nice. Just rewind and just keep going until you figure it out, fix it. That'd be so cool. So we have like so many ideas of where we're gonna go from here, and we're really, really excited about where we are as well. And we're excited to discuss it with you. But if you take nothing else really from this talk, the key insight for us is that like we weren't respecting our UI state as a full-on computer science problem. And once you start doing that, it has benefits that extend like to every part of your development process. Like from your design like sprints to your code and like how you reason, how you maintain, how you do everything. And that concludes the polished section of the presentation.